Okay, so now we're going over questions 4 through 6 on the linear functions and models page. And number 4 says Maria Correa's new car costs $280 a month for car payments and insurance. She estimates that gas and maintenance cost 15 cents per mile. Express her total monthly cost C as a function of miles during the given month. So she wants to express C. Remember, that means that you want to use a C equals equation. And as a function of the miles. So as far as cost goes, her mileage is going to be 15 cents per mile. So 0.15 M. We're going to use M for miles. And then her monthly cost just for the car payment itself was $280. So here's your linear expression or your linear equation for that. Now, if it's function notation, you would want C of M equals 0.15 M plus 280, because this would be function notation where you're saying that your independent variable is M. For part B, it says what is the slope of the graph of the cost functions, and what does the slope represent in the context of the problem. So the slope obviously is the 0.15, and the reason why that's the slope is because they're doing it as a function of miles, and it's 15 cents per mile. So the slope is 0.15, and it means that for every 1 mile driven, it will cost 15 cents in gas and maintenance. That's how you answer the question for 4. Number 5 is, it's sneaky. Number 5 says, the last test that Mr. Clements gave was so hard that he decided to scale the grades upward. He decided to raise the lowest score of 47 to a 65 and the highest score of 78 to a 90, and find a linear function that would give a fair way to convert the other test scores. So if we want a linear function, what we're going to want to do is we're going to have to show the map. So what happened was the first or the lowest score was a 47, and they want that map to erase to a 65. And then the last score, or the second one he talked about, was the highest score, and that was a 78. And they're going to map that to a 90. Well, to me, this looks like writing an equation of a line given 2 points. So the first thing that we're going to need to do to write a linear or find a linear function is we're going to have to find the slope, pick a point, solve for B to get what they're looking for. So when I do slope formula, I'm going to use my y minus y over x minus x, or y2 minus y1 over x2 minus x1, and subtract these. Now, I have them stacked, which is kind of nice. So the y's are already kind of together. The x's are already together. And I can just pop them in. So the second y is 90, and the first y is 65. And the second x is 78, and the first x is 47. And we're going to do that subtraction. Got a calculator here. Make it go faster. 25 on top. And 31 on the bottom. So there's our slope. This is the M. And then we need to pick a point, so it doesn't matter what point you pick. I think I'm going with the 90. So I'm going to use my 78, 90. It doesn't matter which point you use. And then we have to put the point and the slope into our y equals mx plus b to solve for b. So the point that I picked was 78, 90. So the 90 is the y. The slope is 25 over 31. Oops. The x, I forgot I was substituting, is 78. And I'm solving for b. So we'll call this a big fat multiply. We're going to want to, now this one looks messy, like way messy. So we're going to do 25 times 78 to figure out what that is. That's 1950. We're going to do 31 times 1, which is 31. And in this stage, what we want to do is multiply through by the denominator all the way across. So we're going to do 31 times 90. That's 2790. When we do 31 times 1950 divided by 31, we're going to end up with 1950. And 31 times b is 31b. Then we're going to subtract 1950 from both sides. And when we subtract that 1950, I got 31b equals 840. And we're going to divide by 31. And it's 840 over 31. And in the context of the question, we kind of have to figure out what that means. And so this, I typed it in, I divided it, and I saw what I got, and it's somewhere around 27. Okay. As far as the y-intercept goes in our linear, we can keep it as the fraction, but I do want to analyze what that means. As a fraction, the equation is 25 over 31 x plus 840 over 31. That would be your final answer if they asked for the linear function that you would use. Now, what does that really mean? Well, let's figure out what the slope is. How much increase are we going to actually give the points? And when I do 25 over 31, this part here is roughly 0.8. Like 0.81, really. And 840 over 31 is roughly 27. And what does the slope mean in context of the question? It means that for every question that they have, they're going to end up with getting an increase of about 0.80 or 0.8 for every question. And he's raising the whole entire grade up 27 points. All right, the last one is number 6. And in number 6, it says, assume that the sales of a certain automobile parts company are approximated by linear functions. We're going to use the line for this. Suppose that sales were $200,000 in 2009 and $1 million in 2016. We want to let x equals 0 represent the year 2009 and x equals 7 represent the year 2016. That's going to make life a little easier. So this is what it's going to look like. So I'm going to make a little chart that says, okay, in 2009, that was the earlier one. And they want us to use the x value of 0, and the output was 200,000. And then in 2016, they want us to use 7 for the x, and it was $1 million. And now what they want us to do is first find the equation for the yearly sales. So we have to write an equation, just like we did in number 5. Then we're going to have to find the sales for 2011 and then estimate the sales for 2019. So that looks like what we're doing is just doing a bit of plug and chug from there. So the first thing we need to do is write our equation of a line. So to do that, we need to find the slope. We're going to pick a point. And then we're going to find the b. So first part is slope formula. Slope formula is going to be y2 minus y1 over x2 minus x1. These numbers are large, so be careful you don't lose a 0, especially if you're using a calculator. This is 1 million minus 200,000. And the x's are 7 minus 0. So 1 million minus 200,000 is 800,000. And 7 minus 0 is 7. This is my slope. This is the m. The second thing I'm going to do is pick a point. I'm going with the 0. And then we need to find b. The good news. Here's some good news. If you have a x coordinate with 0, you already have your y-intercept. The b always has 0 for y. So the b is 200,000. We don't have to do any work for that. You have to know that y-intercepts are the b, and the b, it has or y-intercepts are 0, a number. So we already have that. So our equation is y equals 800,000 over 7 x plus 200,000. Now I'm just curious. I want to see what that's going to be. Because if I'm looking at rate of change, I want to know what that means. And x represents every year. So 2009 was the first year. That's why it's at 0. 7 years later, right? 9 to 16 is 7 years later. It went up to $1 million. So what the slope represents is the amount of money for the amount of years. So if I want to know how much money the company is making in income per year, I have to divide those. And when I divide that, I get something real crazy, like approximately $114,286 per year, where they started at 200,000 as their base model money. So that's part A. So this is the exact, and this is like what the unit rate would be. This would be like when you're interpreting slope, you would say that 800,000 over 7-year span means that $114,286 per year they were gaining. Now they want us to find the sales in 2011. In 2011, we have to see what X that would be. If 2009 was at time 0, we want 2 years after that. So we actually would want when X is 2. So I would put, you could put it into either equation. This one might give you something a little easier. Again, when you divide, when you round, it's going to be a little less accurate. So this is times 2 and then plus 200,000. So this looks like approximately $428,572. It might be a little off if you use the fraction as opposed to the unit rate. And then part C says estimate what this is going to happen in 2019. So from 2009 at 0 time to 2019, that's a 10-year span. So we're looking at where X is 10. So I'm going to plug this in and put 10 here. So let's do that. And 1,342,860 approximately. That's what they're anticipating to make in the year 2019.